In A, we want to create a table of values for log base 2 of x. We're going to quickly sketch it as well, just like the log base 8 of x. Log base 2 of x has an asymptote at x equals 0. Just like log base 8 of x, it goes through the point 1, 0. But instead of going through the point 8, 1, it'll go through the point 2, 1. And its shape is the same as before. So if we go to our table of values, x and y, we know when x is 1, y is 0. When x is 2, y is 1. But now we can add some more points to this. What's the next nice point on this graph? What could you plug in for x to get a nice value for y? Log solve for exponents. So 2 to, right? This one here means 2 to the 1 equals 2. If I had 2 to the 2, my y value is 2, what would be inside? What value of x would give me a 2 for a y? Log 2 of 4 would be 2. Log 2 of 8 would be 3. And we could label more points on this graph if we wanted to. We need to get our parent graph drawn quickly. Again, just the green points are the 2 key points that you're going to need for your parent graph and your asymptote, because when we go to graph something new, in this case we're going to graph this with transformations. When we go to graph something new, we have to take the points that we have from our original graph, do our transformations just like we did in chapter 3, and then we can draw our new graph. So if I wanted to graph y equals log base 2 of 2x minus 1, one of the things I might do to start off with is take out a highlighter and just say, I know that this is part of my parent graph. I probably didn't need to highlight the x, because you always know the x doesn't affect your transformations. But that little 2, you want to make sure that you're not thinking that does something. This doesn't multiply x by 2 or x by half or anything like that. That little 2 is part of your parent graph. So when you go from left to right, the only numbers you hit are this bigger 2 and the minus 1. So if you're setting it up just like in transformations, you'd say, well, I had these 2 points originally. What's going to happen to them? And in transformations, we always did this in 2 steps. We did our stretches and compressions first, and then our translations at the end. And so going from left to right, the first thing we hit is a 2. Horizontal or vertical? Stretch or compression? Is it going to affect the x or is it going to affect the y? And in this case, it's going to affect the x. And you're going to multiply your x values by, because it's inside the function, everything inside the function, it's kind of opposite of what your gut would think. And so it's x by a half. There's no number in front, so there's no vertical stretch or compression. And so we end up with 1/2, 0, and here 1, 1. Hit the minus 1. Now, you might have a tough time here deciding, is that minus 1 inside the function or outside of the function? And if it was inside the function, there would be brackets here. so that you could tell that that was inside the log 2. But that minus 1 is afterwards. That means that you're going to be going down 1. And so we end up with 1/2 negative 1 and 1 comma 0. The other thing we're going to look at is what happens to our asymptote. And with an asymptote at x equals 0, a vertical asymptote, the only thing that's going to affect it is if you move it left or right. Multiplying your y values or x values won't change it. And since we don't move left or right at all, that asymptote is going to stay at x equals 0. So what does that look like for our graph? So when I go to graph it, I'll start by putting in my asymptote. Then I'll go and label my points. So I have 1 comma 0 and